All right, so we're going to be talking through IVT, and this one's going to be pretty short because we kind of already did this question, but I'm going to go over it again. So IVT, we're talking about basically a function where we have that closed interval. We're going through those points, and as long as our point is in between the other 2 points, then there has to be an x value where our function would equal that y value that we're searching for. Okay, so first we're going to just kind of review our different types of continuity. So a removable discontinuity would be when we have something cancel out. So we have a hole. A jump discontinuity would be any time we have those like piecewise functions, or if we have like an asymptote. Think about jump discontinuity as I'd literally have to jump from function to function to continue along. Okay. So intermediate value theorem, if f is continuous on the closed interval a to b, and k is any number between f of a and f of b, in the notes we used n, so they'll kind of use constant values interchangeably, then there is at least one number c in the closed interval a to b such that f of c is equal to k. So that same thing, that if we have a continuous function on a closed interval a to b, and that value k is somewhere in between the y value at a and the y value at b, then there has to be an x value where the function would be equal to that y value of n or k, okay, on that closed interval. So the IVT can be used to locate zeros of a function that is continuous on the closed interval. If f is continuous on a to b and f of a and f of b differ in sign, so that positive to negative or negative to positive, then it guarantees at least one zero on the closed interval. It can also be used to prove any number, but is most commonly used to prove zero. So let's look at number 12 again. Use the IVT to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a zero in the interval 0 to 1. Okay, so just like last time, we want to find what f of a and f of b are. So f of a would be equal to 0 cubed plus 2 times 0 minus 1, which is equal to negative 1. F of 1 would be equal to 1 cubed plus 2 times 1 minus 1. So that would be equal to positive 2. Okay? So f of 0 is less than 0 because it's negative, and f of 1 is greater than 0 because it's positive. So we went from negative 1 to 2, so we had to go through that 0. So therefore, f of x has a 0 on 0 to 1. Okay, so pretty short and sweet.